Good morning, everyone. My name is Madhura Chavan, and I am a PhD student at Texas A&M University. I'm working with Dr. Marybeth Husty for my PhD research, and today I'll be presenting a review of key parameters affecting the punching shear strength of post-tension slabs. Post-tension slabs are quite common in building structures. However, we have very few tests on post-tension slabs which are subjected to direct shear. So a comprehensive database was prepared of the available test data in the literature to investigate the current design provisions and recommendations. So the objectives of today's presentation are to present a summary of the comprehensive database that was prepared, investigate and compare the two-way shear design approaches of different design codes, and to discuss the influence of various key parameters affecting the punching shear strength of pre-stressed slabs. So the database that was prepared summarizes the specimen parameters and the measured shear strength of the slabs available in the literature. 92 post-tensioned interior slab column connection tests were collected for the database. The slabs included in the database do not have any shear reinforcement. They had square and circular supports and were all tested under direct shear. Most of the slabs were individual connections, while 10 of them were multi-panel specimens with interior and exterior columns. The slabs in the database have both bonded and unbonded tendons. This figure here shows the distribution of database with respect to concrete compressive strength F prime C and the average effective pre-stress FPC. ACI 318 limits the maximum value of concrete compressive strength at 4,900 psi and the maximum value of average pre-stress at 500 psi. For the purpose of calculating the punching shear strength of the slabs. A related commentary in ACI indicates that this was due to the limited data that was available at the time. It is apparent from the figure that the tests included in the database include a wide range of values for F prime C and FPC, and about 50% of the test slabs included in the database have F prime C above the specified ACI limit. So the two-way shear strength was for the slabs in the database was calculated based on ACI provisions, the Canadian code provisions, and the Euro code. The equations used for calculating these punching shear strengths are summarized in the table given. The F prime C value limit for ACI and the Canadian code are pretty similar at around 5,000 psi. However, for Euro code, it is pretty high at 13,000 psi. This figure compares the shear strength ratio calculated for different codes discussed in the previous slide and their relationship with the concrete compressive strength. It can be observed that as the concrete compressive strength increases, the level of conservatism of the slab also increases. This figure shows the relationship between shear strength ratio and the reinforcement ratio. The slabs included in the database had very low reinforcement ratio, which was less than 1.4%. The table on the side gives a summary of the statistical data for shear strength ratios. It can be found that the Eurocode 2 actually gives more conservative results for pre-stressed slabs. It also has less number of slabs with shear ratio less than 1. The punching shear database was also used to evaluate various key parameters and study their influence on the punching shear strength calculated using ACI provisions. The figure shows the relationship between shear ratio and the effective depth of the slabs. It was found that the level of conservatism decreases for slabs with effective depth greater than 6 inches, and this indicates that a size effect factor may be necessary for slabs which have thicknesses greater than 10 inches. However, the current database is limited to slabs with effective depths less than 8.4 inches. As mentioned previously, the ACI limits the compressive strength of concrete to be used for calculation of punching shear strength at 4,900 psi. The figure shows the relationship of compares the shear strength ratio calculated using the ACI provisions with the F prime C limit and without the F prime C limit. It was found that the level of conservatism, even though it decreases with when the measured values of compressive strengths were used, no additional points fall below the 1.0 line, which indicates that the ACI limit for F prime C could be increased to 8,000 psi or 10,000 psi. This figure shows the relationship between shear strength ratio and the reinforcement ratio. The reinforcement ratio was calculated over the effective width of the slab, and it can be seen that most of the slabs have low reinforcement ratios. All of them were below 1.5%. The minimum area of bonded flexural reinforcement required for pre-stressed slabs is given in section 8623 of ACI 318. On reviewing these provisions, it was found that even when 2 to 3 times of the minimum required reinforcement was provided, the shear ratio still can be below 1.0, which indicates that the minimum required flexural reinforcement for pre-stressed slabs may be too low and needs further investigation. For comparison, the minimum reinforcement specified for non-pre-stressed slabs was also investigated, and it was found that except for 3 slabs, all other slabs with shear ratio less than 1 had bonded flexural reinforcement less than the AS min required for non-pre-stressed slabs. So the initial analysis suggests that the minimum required bonded flexural reinforcement for pre-stressed slabs is too low and can be increased to the minimum requirement for non-pre-stressed slabs. Further studies are underway to investigate the appropriate amount of bonded flexural reinforcement for pre-stressed slabs. Finally, to avoid the punching shear failure, the two-way shear strength of the slab should be greater than the flexural strength. One way of ensuring that could be limiting the two-way shear strength of the slab to the minimum of the shear force at flexural failure and the two-way shear strength calculated using the ACI provisions. Doing so gives a lower bound for all except for the 3 slabs. To summarize, I would like to say that we have a very limited data for pre-stressed two-way slab column connections under direct shear. On comparison with other on comparing different design provisions for different codes, it was found that Eurocode 2 gave more conservative results as compared to ACI and the Canadian code. There was a downward trend in the level of conservatism for slabs with effective depths greater than 6 inches, and therefore a size effect factor can be considered for pre-stressed slabs with thickness greater than 10 inches, which is consistent with the non-pre-stressed slabs. It was found that the ACI equation is relatively conservative when the measured values of F prime C are used, and therefore the data suggests that the limit on F prime C can be increased to 8,000 to 10,000 psi. It was also found that the minimum bonded flexural reinforcement for pre-stressed slabs is pretty low and can be increased to that required for non-pre-stressed slabs. The two-way shear strength equations and the minimum bonded flexural reinforcement requires will be further investigated in the study. Thank you for your time.